So this is a demo of the I2C communication between two Arduinos. So I've taken two AtMegas and I've connected them through the I2C link between the two of them. So I'm going to use this camera to show you my setup. So here are my two Arduinos. They are currently working together. I have a worker which I've put an R here as receiver and S for sender. So this is the master or controller, and that's my worker. And I have here a potentiometer, ground and VCC on one side, and then an analog pin on the other here connected to the analog pin. And so this guy will read the potentiometer, and whenever the value that it's reading is different from the previous value it read, then it's going to send over the serial link. So you see here, let's see if we can see that closer. I'm connected to the SCL and SDA pins, 20 and 21 of the AtMega. And note that with this serial communication, which is different from the other serial communication, the IC2, then there's no crossing of wires. So the SDA here, or SCL, orange is SCL. SCL is connected to SCL, and SDA is connected to SDA. And of course, I have a ground connecting the two together for the return of current. So that's basically as simple as it gets. It's pretty good. So let's take a look right now at the sketch. So the controller is right here. So that's the controller. The address of the worker is going to be 9, so I'm defining that as a constant. And the potentiometer is connected to analog pin 3, so that's that. And the last value read, I'm going to keep track of the last value read from the potentiometer. And if what I'm reading is different from the last value, then I'm going to send that over the serial port. So in the setup, the only thing I have to do is to wire.begin. Of course, I'm including the wire.h header of the library. The wire library is where everything is located for that, as all the functions we need. So setup, the only thing I need to do is to wire.begin. And then in a loop that is repeated over and over and over, I'm waiting a little bit. I don't want to really stress that Arduino, but every 10th second, so 100 millisecond is 1/10 of a second. Every 10th of a second, I'm going to look, I'm going to analog read the potentiometer. If what I'm reading is different from what I read before, then I'm going to send it. So I'm reading this, and if you remember the analog to digital converters on the Arduino are 10-bit converters. And what it means is that the value that we're going to read is going to be between 0 and 2 to the 10th, 1024, but not included. So from 0 to 1023. However, in the serial communication between the two, I can only send a byte. So 1000, the maximum 1023, the maximum number I can store in a byte is 255, which is a quarter of 1024. So I'm going to divide by 4. So this is what I'm doing here. I'm changing the value. I'm scaling it by 4, basically. All right, so that's what I'm doing here. That's why the divide by 4. I'm making sure that whatever I'm getting is going to fit in a byte, so I'm dividing by 4. And then if that is different from the last value that I had read, then I'm going to wire begin transmission, and here is my worker address. So that's how the worker kind of initiates the transmission. So I have something to transmit. This is my address. And then we'll receive an acknowledge of some kind from the manager, but all this is done internally in the wire library. Then we're going to wire write the value, and then end the transmission. So very simple serial communication. This is it. And then at the end, I'm going to say value equals last value. So I'm updating the last value. So if my potentiometer is not touched at all, then there's going to be no communication between the two. This is what the worker is going to do. So it's right here on this side. Include the wire.h library as well. By the way, that original example that I've taken is available here on YouTube. So worker address is 9. That's to be the same as here. because they're talking to each other. So the controller on this side will have to know who's talking. We're going to use the onboard LED, so that's pin 13. And then I'm creating an integer that will hold what I'm reading from the manager. And that's what's going to become the frequency, the period, the amount of time that I'm waiting between blinking on and off. This is event programming. So here I'm saying I'm going to use a function called receive event. It's going to be called by the library, the wire library. And all I have to do here is I have to kind of say, all right, so that's the name of that function. It's going to be defined later on in the code, but I'm putting it up there so that when I'm going to use it here, then the C compiler will not be confused. So, but the code of receive event is going to be given down there. So let's take a look at setup first. Setup, serial begin, that's just for debugging. I wanted to show on the screen the information that was received from the master controller. So I want to initialize the serial communication to the serial monitor. So that's only for communication between the Arduino and this computer. And then the LED pin should be programmed as an output. And then I'm initializing a communication saying, okay, I'm going to be a worker here, one of 127 possible workers that the master controller can talk to. And this is my address. And if something is being received, being sent to me to that address, I would like the receive event function to be called. So that's what I'm doing here, wire.onReceive. I'm specifying, and all I need to do here is I'm not calling the function, I just need to give the name. The C compiler needs to know where it has to jump in my code to which function it has to jump to whenever there's an event. So just the name, no parentheses, not passing anything, that's what is expected here. All right, so here is the event function. When it's going to be called by the wire library, it will be given a number of bytes that have been received. I don't care about that. I'm always expecting it to be 1, so I'm never going to use n, but I have to declare n as being a parameter that will be passed. So val, which is an int, so I'm typecasting C, and I'm clearing any other upper bytes in there, depending on how big the integer is. And then just for debugging, I'm going to print C, I'm going to print a space, and I'm going to print val. So I'm going to print just the character and the integer corresponding to it. So that's that. And then my loop function, what it will do, it will digital write LED high. So it's going to turn the LED on. It's going to wait 100 plus val. Then it's going to turn the LED off. Then it's going to wait 100 plus val. So 100 is so that if val happens to be 0, I don't want the LED to be on, to just keep on blinking very, very, very fast. I wouldn't be able to see the blinking. So 100 means that, well, at least it will be on and off at least a tenth of a second. So that's that. All right, so they're loaded. So let's take a look now back to this. All right, so I see my little LED blinking there. I'm going to try to show the whole setup here. We see the LED blinking, so that's the one I'm looking at, right? That little LED. And as I'm going to change the potentiometer, I should be able to make it blink. So now you see it's blinking slower, and then I'm going to turn the pot the other direction, and it should be changing. Okay, so here I'm kind of have a bad contact. It's not very easy to get a good contact with the potentiometer. And what you're seeing also, so let's see, let me try to make it blink as fast as I can. Small values. Okay, fairly small, fairly fast blinking. Okay, and I'm going to bring on the screen the serial monitor. So we're going to be able to see what this serial monitor is doing. It's this part, print C space and value. So for small numbers, there's no ASCII characters corresponding to small numbers. So that's what's going on here. I'm seeing some unprintable character space. And for large numbers, and you see that by touching a tiny bit, I'm going to be able to find a value of the potentiometer that is in between things. All right. So now, and I'm not touching it anymore, but you see that the potentiometer its value is kind of oscillating slightly. And these are the numbers that we're reading from it, and the ASCII characters corresponding to that. And so, because the serial communication exchanges characters, that's why I want to look at them as characters. But it's really the number that I'm interested in, because I want this to become a number of milliseconds. All right. And so you see that at some point it stops. And the reason that it's going on and off from time to time is that the vibrations, my being at the computer here and talking, there's enough vibrations in the table and around that the potentiometer is vibrating a tiny bit, and that's enough for it to send slightly different values. All right. So anyway, that's a demo of the serial communication with I2c.